Okay, so in this section of integration, we are focusing on the reverse. We are focusing on seeing integration as a reverse of differentiation. And we are also looking at some partial fraction, the integration regarding partial fraction, or it will involve some trigo identity. Okay, so the idea of reverse of differentiation can be quite wide. So there must be a basic that you need to understand. So I'm only showing you like 3 examples of like how do you see integration or as a reverse of differentiation, but it can be quite wide. So usually there will be a first part of the question will be differentiation. The second part will be reverse. Okay, so I repeat, the first part is always differentiation, and the second part is always the reverse idea. Okay, so that's the general idea first. So because this in this teaching worksheet, I'm focusing on the reverse, I will not be going through so much on the differentiate part. So you will need to see whether you are able to get the differentiate part or not. So I'm assuming in the way that you should be able to get the differentiate part. So when I'm going through this example, like for example, here I'm going through example 1, 2, 3, I won't be focusing on the differentiation part. I'm focusing on the reverse. Okay, so if you look at example 1, part 1, they say show that differentiate this is equal to this. So basically, they are just asking you to differentiate. And hopefully, you should be able to see that it's a product rule. So I will not be showing you the product rule. So you give it a try. You shouldn't have any reason to get it wrong at this stage already. You have done like differentiation for so long. So this is a product rule where square roots is constant. Okay, and then I'm focusing on part 2, which is a hence. Hence means you got to use the result of part 1. Okay, so the result will be this. So if I'm going to be doing part 2, how can part 1 help me? So I need to reverse it back. So the reverse will be integrate. So I apply my product rule to differentiate. So that means, right, from part 1, the implication is if I integrate this. So I'm not answering the question yet. I'm trying to use the idea of hence first. So I must know what does part 1 help me with. So because I use the product rule, I managed to get a fraction. That means if I integrate this whole fraction, I will be getting back the original product. So that is the idea. Okay, so of course you can add a constant. So this is the hence idea. That means you undifferentiate it. Some students will see as you undifferentiate it. Okay, so the undifferentiate is integrate idea. But if you try to use the reverse, you realize that the question is different. You realize that the question is different. Do you realize that the question has a +7? Okay, so, but the numerator looks almost like the undifferentiate part that you are doing. Okay, so here I'm going to kind of label this. This is the hence. I undifferentiate it. So when I undifferentiate is the integrate. I undifferentiate from my differentiation. Okay, but the question is asking me for 15x squared minus 8x plus 7. So I'm somewhere near and not near. I got the extra 7. So what do I do with the extra 7? So actually, I'm going to see as I'm going to share the denominator. So I'm going to share the denominator. So I'm going to share the denominator. So I kind of split the huge fraction. And when I split the huge fraction, I got 2 separate integration. I got 2 separate integration. And do you realize that this is your hence part? So integrating this is actually this part. So you are integrating the fraction that you get from your product rule. So that means, right, I can put in my number one, and I'll get x squared. I can ignore the constant first because I still need to integrate this part. So this part, if I integrate, I use my basic formula to integrate. So I'm using my basic formula to integrate. So the basic formula is you add the power, you divide by the new power with the A. So that formula is the basic integration formula. You can find it in integration number 1 in my worksheet. So work it out carefully. Go and punch calculator if you need to. So punch calculator for this part. So if you punch calculator for this part, you will get a 7/3, and this will be your square roots. Okay, so that will be my answer. So the hence come from the undifferentiate. So I use product rule to get the differentiated answer, and I undifferentiate it. Undifferentiate is the integrate. Okay, so this is the reverse. So some students, they can't reverse that well at the start. So they keep having mind block. They will forget that they can actually undifferentiate. So integration is like undifferentiated. You undo the differentiation. Okay, so that is one example. You will need to try the product rule. Okay, I'm not showing it in the explanation because the focus is on the reverse. Okay, let's go to the next one. The next one for part 1 is a product rule as well. Okay, so again, I'm not showing you. Okay, so I'm not showing you. I'm just giving you the answer. So I find out that I get -2 EX sine X. Okay, so you check out whether you can get the answer or not. If not, you got to check out my answer sheet, what went wrong. Okay, so let's understand the idea first. That means, right, if I differentiate this using product rule, I would have gotten this. So I differentiate this using product rule, I've gotten this. So if I'm going to be doing the hence part, I'm going to undifferentiate it. You undo the differentiation. So how are you going to undo the differentiation? You undo it by integrating. So integrating this will give you the original U and V. So usually, right, I will just be focused on undifferentiating first. After I manage to undifferentiate, then I will check out the question. I will check out my undifferentiate, and then I will check out the question. So if you check out where is the difference is the -2 and the 5. So currently your undifferentiate got a -2. So essentially you need to get rid of the -2. So you can kind of pull this constant out from the definite the integration, and then you divide over. So this is exactly what I'm going to do. I'm going to pull out the -2, and then I'm going to divide over. So I'm going to pull out the -2, and then I divide over. And then because the question needs you to have a 5, I'm going to introduce a 5 by multiplying on both sides. So I'm going to multiply on both sides the value 5. Oh, I forgot. After I undifferentiate, I must put a C. So generally, we'll just put a C. So the idea is actually very simple. After you differentiate, you undifferentiate. So undifferentiate is equivalent to integrate. So you see what you manage to undifferentiate first, and then compare it with what the question wants. So usually there's a little bit of manipulation. So okay, here, okay, another one here. Okay, so Okay, I'm not going to be showing you how to differentiate this. So this one maybe you find a bit difficult to differentiate. So anyway, you're going to be using the formula. Differentiate ln fx will be 1 over fx. And then you got to differentiate your fx. So in this case, this is your fx. So you got to apply this formula and you give it a try. So I get a very nice answer. So in the first place, this can be a technical challenge already, differentiating it. So sometimes some students will lose focus because they spend a lot of time differentiating or then they find very difficult. Then after that, when they look at second part, they didn't know what to do. Okay, so if you look at part 2, I'm supposed to use the answer in part 1. So how am I supposed to use the answer in part 1? I'm supposed to undifferentiate it. So I'm supposed to undifferentiate it. That means from part 1, I can understand the undifferentiate idea. So the undifferentiate idea is integration. So I will get back. So I try to undifferentiate first. After I undifferentiate, okay, which is integrate, I compare with this and this. So you must always undifferentiate. Then there's always a bit of difference. So what do you have and what does the question want? So the difference is the 5 over 4, which is very easy. You just need to multiply 5 over 4 on both sides of the integration. So manipulating numbers is easy. So you just need to multiply 5 over 4. Okay, and you will get what the question wants. So that's it. That is an undifferentiated idea. So very simple. In a nutshell, it's just you try to undifferentiate, which is equivalent to integration. After you undifferentiate, then you see what kind of manipulation is needed to answer the question. Usually there is some amount of manipulation. You can manipulate numbers, but you cannot manipulate algebra inside. So that's one of the mistakes. Some students, they manipulate X inside. So that's not a correct technique. Okay, so do the undifferentiate, aka integrate, and then you compare what you have and what the question wants. So that is an idea that you will need to practice.